This is JEE Main 2020 question. So I'm giving all of you a hint how to solve this question. So basically what we have to do is, there are three sections of the Y, if you can see in the figure, 1, 2 and 3. So we have to find magnetic field due to all the sections, and we have to find magnetic field at the center of the circle. So let us see. So the wire is very long, A, B, D, M, and DC. So the wire is very long. So if we talk about wire 1, Kulsum got A. Okay, let us see. So any idea how to solve it, Kulsum? For wire 1, what we can do is, we have to find magnetic field at this center, this point. So basically it will be situation like this. It's very long wire from infinity, and the center is at its end, and radius is r. Radius of the circle is r. Of radius r. So this distance will be r. So suppose this point is P, which is at the center, or we can say O also. So here we can find magnetic field at point A by using the formula. What is the general formula? We know that general formula, or in the last class we have found the magnetic field due to half wire, right? So what is the value? Anyone? What will be the magnetic field at
mu
point?
naught I by 4 pi r.
Correct. So B at O will be mu naught I by 4 pi r. So this is due to the half portion of a infinite current carrying wire. Now we will see for wire 2. Similar is the case for wire 2. So we see for wire 2. So for wire 2, what will happen is we have to find magnetic field at this point. So we have to use that formula. So for wire 2, what will be the value of theta? If you see here, actually we were taking this angle. So here what will be the value of theta 1? That is the main challenge, to find theta 1. So if you see here, this angle, because this angle is 90 degree and this angle is also 90, this angle must be 45 degree, right? This angle must be 45 degree. So here theta 1 will be 45 degree, and what will be the value of theta 2? Since the wire is going to infinity, so theta 2 will be 90 degree, right? Understood?
Yes, sir.
So for wire 2,
So can you please repeat?
let us see. What happens is, in the last class, if you were present, like what we have done is we have calculated the magnetic field at point P. Suppose this is a point P, and what we have done, suppose this is a finite current carrying wire, and if you want to find the magnetic field at point P, suppose current is I, so we have derived the formula, right? Suppose one angle is taken as theta 1 and another angle is taken as theta 2. Then we have derived a formula for magnetic field at point P as suppose this distance is r, then we have calculated magnetic field mu naught I by 2 pi r cos theta 1. Was it cos or sine? We have discussed it. I think it was sine, right?
Yes, sir.
Yes, sine theta. Sorry. So sine theta 1, sine theta 1 plus sine theta 2. This formula we have to by heart. This is very useful formula. We have seen it. So now what will happen if
So it's 4 pi r, sir.
it was 4 pi, right? It was 4 pi. So mu naught I by 4 pi r Sine theta 1 plus sine theta 2. Now we have also, if you see here, I am going to remind you back. Let us see that better. You see here in the last class or before last class we have discussed this. So we have found the magnetic field. If you see, you can see this formula. We have found the magnetic field at a point P by using this formula mu naught I by 4 pi r sine theta 1 plus sine theta 2. Now like now we have discussed the special cases like if the wire is infinite, so we can take like theta 1 should be 90° and theta 2 also 90°. So we got magnetic field as mu naught I by 2 pi r. Then suppose we have to find magnetic field at a point P situated at one end. So in that case, this happens. So we have to decide the angle according to the location of the point, whether it is at the center or whether it is at the end. If point P is at the end of the wire, this is the wire, and point P here is at the end. So in that case, one angle becomes 90°, another becomes 0°. So this is how we calculate the magnetic. Then we have discussed for curved wire and all, right? So same is the case here. Now you can see here, using that we can say that here theta 1 is 45° and theta 2 90°. Understood?
Yes, sir.
So
Yes, sir.
now what we have to do is we have to put the formula. So in this second case, we can find magnetic field. For second wire, magnetic field at the center O will be equal to mu naught I by, the distance is almost here r, so that is mu naught I by 4 pi r, and one angle is 45° and one angle is 90. So sine 45° plus sine 90. So here we will get the magnetic field as I by 2 pi r. So for wire 2 we will get magnetic field at the center as mu naught I by 2 pi r. One angle is sine 45°, so that was 1 by root 2, one is like this. So this is the magnetic field due to second wire by 2. Now if you see what will be the direction due to wire 1 and 2? What will be the direction of magnetic field due to wire 1 at center?
Inwards.
Correct, it should be inwards. So here magnetic field obviously it will be inward, and what is the direction due to second wire? Wire 2,
Outwards.
yes, it should be outwards. So magnetic field due to, can all of you understand how we are taking the directions? How we decide inward and outward? Everyone got it? Kulsum, Samaira, have you understood how we have taken inward direction and outward direction?
So can you please explain for the wire one?
Why inward and outward?
Yeah.
The direction we have already discussed. Suppose
Sir, actually I was absent in the previous class.
yeah, So how we find direction is like we have to apply right hand rule, and let me get back to the previous lecture. This is how we find direction. We are applying right hand rule, so RH rule. So in that, what we do is this, the general idea is like if the point is right side, the magnetic field is inward, and if the point is left side, magnetic field is outward. You can also find it by like you place your thumb of your right hand finger. How it is right hand rule? You place thumb of your right hand finger along the current of carry along the current in the wire, and curl your fingers along the along like this, like the way I have given the arrow. So place your thumb along the current and curl your finger like shown in the figure. So you will get the magnetic field. Like if the point is right side, obviously curling will go inward, so magnetic field will be inside or inward. And here obviously curling will come outside, so magnetic field is outward. Either this way you can remember, otherwise you can directly remember if the point is right side, magnetic field is inward. If the point is left side, magnetic field is outward. But sometimes it gets difficult to analyze what is left side, right side. So it is always better to apply right hand rule. For that, you place your thumb along the direction of current and curl your finger. Curl your finger like if I can explain in the video. So uh, can you see my hand?
Yes, sir.
So suppose this is the current carrying wire, and current is going from like in upward direction, like this, in upward direction. You place your thumb of your finger along the current carrying wire and curl your finger like this. Curl your finger like this. So these points, you can see at right side points, curling will be like this. So magnetic field will be inward. And at these points, curling will be like this. So magnetic field is always outward. Understood?
Yes, sir.
So this is how we find direction of magnetic field due to current carrying. And if the points are on the wire, like you can see here, if the point is on the wire, magnetic field is always zero. If point is on the wire or along the length of the wire, theta becomes zero and magnetic field is always zero. So if any point lies on the wire or along the direction of wire itself, magnetic field is always zero. If the point is right side, magnetic field is inward. If the point is left side, magnetic field is outward. But this is for current going in upward direction, right? So it is always better to find by right hand rule. If current goes down, then direction will change. If current goes down like this, then at this side magnetic field will be inward and this side magnetic field will be outward. But again, right side will, you have to see from the perspective of direction of the current. So it's always better to place your finger along the direction of current and curl your finger. If curling goes inward, magnetic field will be inward. If curling comes out, magnetic field will be outwards. Got it?
Yes, sir.
So this is how we find the direction. Now you can see here due to wire 1, if you see, where is the wire 1? This one is the wire 1. This wire we have named as wire 1. So due to this, and this wire 1 is going from A to B to this wire is up to this, or this center is right side. So obviously due to this wire, magnetic field will be inward. So we have given the cross direction. Now due to the second wire, this one is the second wire, wire 2. So due to this, obviously magnetic field will be outward. So we have given this side. Understood?
Yes, sir.
Now the third portion of the wire, which is third one is circular, right? Third portion is actually circular portion. The wire is actually, if you see, wire is actually A, B, B, then it comes M, then it comes N, then D, then C. It is like this. So now the third portion is circular portion, and due to a circular portion of a wire, we know that magnetic field. So for third wire, we can say, or for third section, the point 2 is at basically at the center, and current is going in anti-clockwise direction like this. So what will be the value of magnetic field at the center? Anyone?
mu naught I by 2r.
Correct, mu naught I by 2r. And what will be the direction?
Outwards.
Correct, outward. It should be outwards. Everyone understood how
Yes,
it
sir.
comes outward? And I think you all know this formula, mu naught I by 2r. You have to remember this magnetic field at the center of a current. I have derived it also. Magnetic field at the center of a current carrying coil is mu naught I by 2r. So this is the formula for magnetic field. I'm getting a phone, please wait. Sorry for interruption. So we have got the magnetic field B is equal to mu naught I by 2r, and obviously the magnetic field will be in the outward direction. Now we to find the total magnetic field, what we will do, we will add all the magnetic field due to first wire, due to second wire, and due to third wire. So what was the magnetic field due to first wire? It was mu naught I by 4r, mu naught I by 4 pi r, and we will take inward as we can take outward as positive, so we will take inward as negative, so we'll put minus sign, and due to second wire this was this, so I am putting it minus sign inward, and due to second wire it was mu naught I by 4 pi r 1 by root 2 plus 1. This was in the second wire. It was 4 pi r, right? By mistake we have taken 2 pi r. It should be 4 pi r, right? And due to third wire, it is also like mu naught I by 2r. So what will be the value of magnetic field? We can take mu naught I by 4 pi r common. So we will get 1 by root 2 plus 1 plus 1, and then minus 1, and then we are getting mu naught I by 2r. So mu naught I by 2r is common. So here we have to apply 2 pi, right? Actually like this. So what is the value we are getting? Mu naught I by 4 pi r, and 1 and 1 will cancel out. So 2 pi plus 1 by root 2. Everyone understood this? So see which option is matching with this. Mu naught I by 4 pi r, 2 pi plus 1 by 2. Mu naught I by 4 pi r. Or either what we can do, we can also do it like 2 we can take outside, so we can simplify it also. So after simplification we can get, if we take 2 outside, so we will get mu naught I by 2 pi r, right? Pi plus 1 by 2 root 2. We take 2 outside. So see which option is matching with this. Mu naught I by 2 pi r, pi plus 1 by 2 root 2. Mu naught I by 2 pi r, mu naught I by 2 pi r, pi plus 1 by root 2. Is there any mistake somewhere? Cross check it. Mu naught I by 4 pi r. First one is correct, then second is mu naught I by 4 pi r. The angle was 45 degree plus 90 degree. And the third one we have got mu naught I by 2r. Mu naught I by 2r. R is the radius. So this we have got 1 by root 2 plus 1 minus 1 and 2 pi. Mu naught I by 2 pi r. 4 pi r, we got 2 pi plus 1 by root 2 mu naught I by 2r. So we'll get mu naught I by 2 pi r, 2 pi plus 1 by root 2. Two are outside and one is inside. A, B, D, A, B. Oh, we are making one mistake. I think we may be D. The wire is A, B, D, M, M, and D, C. So actually the wire is, if you see here, what happens, if you see what, where is the wire is going on, like if you see here, the wire is A, B, D, M, and D, C, right? It means the wire is coming like this: A, B, D, A, B, D. It is not moving to A, B, D, M, N, C, like this, M, N, D, C. So if you see first part, if you see wire 1, we have to reconsider due to wire 1. The situation is not like this. If you see wire 1, the situation is not like this. Getting my point? Since wire is, turn at this point B, turning at it is not moving here. Actually, this portion is not straight. This portion is not having any straight wire. Getting my point? So angle will change. For wire 1, if you see what will be the situation, for wire 1, it will be like this. See here. For wire 1, the situation will be like this. Actually, the circle is tangential kind of thing here. So I'm making it a separate wire like this. Yes. For wire 1, actually the situation is like this. The wire is going like this and it is turning like this. So here we are getting the circular portion. Here we are getting the circular portion like this. But wire bends here. The point B is here and wire bent like this. So the center is like this. So for wire 1, what will happen is we have to take the angles. So the first angle is obviously, if you see, we have to see the two ends. One end is here and the second end is at infinity. So the center is here. So, and we were making the angle, we have to see the, so we have to see this angle, right? What we were doing, we were drawing the perpendicular from this point to the wire, and then we were seeing the angle. So we have to see this angle, and this angle is actually 45 degree. Getting my point? So the one angle will be 45 degree here. Yes, theta 1 will be 45 degree and theta 2 is obviously 90 degree. The situation is like this. Understood?
Yes, sir.
So that is the thing. So here, while calculating due to wire 1, when you are calculating magnetic field due to wire 1, so for wire 1, what we will write? For wire 1, the field will, the point is coming like this, the current is coming like this, and the center was here. So and we have to take the angle in the direction of current, right? So the point O is here and this angle is like we were taking angle. If you see in the diagram, if you see in the general situation, what we were doing, we were taking a point and we were taking angle of two ends with the middle point, like we were taking this angle and this angle like this. So here the point is like this, so we have to, you know, we have to draw lines from this point to two ends. So one end will be like this and the point is like this here. So the angle we have to see, that point should make with the perpendicular direction. So this angle is actually 45 degree and the other angle is 90 degree. So the direction of current is like this. The current is going in this direction and we have to take angle with that direction. So what was the net magnetic field we were getting? We were getting 2 pi 1 plus 2 pi. So actually what will happen is that in that section we will have one more term of 1 by root 2, right? Due to that terms of sine 45 degree, here we will have one more term of sine 45 degree, right? So that will be added and we will get the final result as 2 pi plus 2 by root 2. Getting my point? 1 by root 2 term will come twice. Understood? Since we are
Yes.
adding sine 45 term. So what we will get? We will get the net field as this will be 2 by root 2, right? So 2 and 2 will be cancelled out and we will get the magnetic field as mu naught I by 2 pi r and we will get as pi plus 1 by root. This will be the net magnetic field. Let us check which option is matches with this. Mu naught I by 2 pi r. We were getting mu naught I by 2 pi r, pi plus 1 by root 2. Pi, I think option 1 is matching with that. Mu naught I by 2 pi r, pi plus 1 by root 2. Understood? So actually in the first case of the wire or for the first wire, that is not exactly at the end. The point makes some angle with the end of the wire. That is why we have subtracted. We have to take one angle, one term of sine 45 degree also. Understood, everyone?
Yes,
Anyone
sir.
having doubt, please ask.
Sir, can
Krishna,
you
Samaira.
explain the case one again?
The case in the case one, we have taken the magnetic field actually this. We have considered the actually we have considered this point O at the end, right? First we have considered by mistake, we have considered this point at the end, but this is not the case. Actually wire is not going up to the level of O, it turns before, right? And the point is here. So here theta 1 becomes 45 degree and theta 2 becomes 90 degree. So magnetic field will not be exactly mu naught I by 4 pi mu naught I by 4 pi r. Also it will be plus plus a sine 45 term will be added, right? So due to case of first wire, what will be the exactly what will be the magnetic field? Mu naught I by 4 pi r 1 plus 1 by root 2. This will be the magnetic field at the point 2 due to the wire in the first case. Additional term 1 by root 2 have to be added. Getting my point? Understood? Since when we have calculated mu naught I by 4 pi r, we have considered theta 1 as 0 degree. But actually that is not the case, since point O is not exactly, exactly here. Actually this is not the case. In this case magnetic field is this, right? The point O is basically above and B, since wire turns here. Understood?
Yes, sir.
Actually the point O is not exactly at the half point. It is slightly above the turning point. That is why theta 1 becomes 90 degree, 45 degree. This we have calculated mu naught I by 4 pi r only when that point was exactly at the end. But here the center O is not exactly at the end. Understood? So this is JEE main
Yes, sir.
question, not much easy. You have to be very careful while considering the angle. Let us do more question based on this so that we can clarify it. Anyone having any doubt, please ask.
So in that case, both case 1 and case 2 terms will cancel out and only case 3 term will remain, right?
No, both will be added, right? Since,
So one is inwards and one is outwards, right?
yeah, that we have taken. Let us see. Let me check. What we have taken mu naught I by 4 pi r. In first case, we have mu naught I by 4 pi r. We have taken mu naught I by 4 pi r with minus sign, right? And mu naught I by 4 pi r 1 by root 2 plus 1. In the second case was outward, right? First case was inward. Okay, mu naught I by 4 pi r. I think you're right. The directions are opposite, right? The directions are opposite. Okay, let us do another question. Meanwhile, I will explain you before ending the class. So the thing is same. We have to take the angle. Somewhere there is a calculation mistake. So before ending the class, I will explain it. This question again. We will not, too much time on this. So yeah, obviously we should take the direction in opposite direction, right? One is in outward direction. You are right in that, and maybe we have to see the direction of angle also. It is going into clockwise or anti-clockwise. So meanwhile, you all attempt another question, then I will explain it before ending the class. I will come back to this question. Before that, let us attempt more questions. The main questions. Now all of you solve this question number 70. This question I also found very good question. So all of you attempt question number 70. So till now, all of you attempt this question number 70. This question based on JEE. This is basically based on force on a moving charge. And also we have to see the magnetic field also due to a current carrying wire. Anyone got any answer? All of you trying this one?
Yes, sir. So option B.
You got option B, opposite to OY. Anyone else? So it says a very long straight wire carries a current I at the instant when a charge Q at point P has velocity V as shown in the figure. The force on the charge is. So we have to find the force on the charge. We have to basically find the direction of force on the charge. So it is very, I think, very basic. It seems to be difficult, but it is not so difficult. First, we have to find the direction of magnetic field here, right? So what will be the direction of magnetic field here? Inward, right? The magnetic field will be inward. So you can say if it is Z, so magnetic field along will be along minus Z, right?
Yes,
E
sir.
is along minus K. So we have to find force. We know that force is Q into V cross B, right? So here V is along X direction. If you can see here, V is along X direction cross B is along minus K direction. So it's I, J, K. We are taking I cross K. So it will be minus J, right? I cross K will be minus J, minus minus plus. So it will be J, right? J means it should be along OY, right? It should be along, force should be along OY. Getting my point? Or you can also see from right hand rule, if you are moving from B to B, QV cross will be along this direction. If
Sir,
you,
but it is minus K, right?
which one is minus K?
So minus K.
Yeah, minus minus plus will be right. If you are doing I cross K, you can see from here also. If you are doing, you take minus outside, so it will be I cross K, right? So we are moving like this, right? If you move like this, I cross J, J cross K. So I cross K is minus J, and also minus is outside. So it will be minus of minus J. So it will be plus J. Or you can see also from here, from the diagram, generally I avoid using I, J and K directly. You can also find it. Like you can see here, the V is along this direction and B is along this direction. So what will be direction of V cross B? Obviously it will be along this direction, OY. If you apply right hand rule, V cross, what will be the direction of V cross B? Perpendicular to both A and B, it should be along OY. Getting my point?
Yes, sir.
So the correct answer is A. Both of you got this, Samaira, Kulsum? Understood?
Yes, sir.
Or any doubt, please ask. Okay, coming back to the previous question, actually we were making one mistake there. Our answer is correct. The correct answer is actually that one. We were getting option 1 right. So the correct option is 1A only. But what mistake we have done is, the mistake was only that angle. But what we have to do is, here in the first case, for the first wire, I am drawing it on a separate page like this. What will happen is, you can see here, the wire is going like this and the point is like this, right? So you can see this diagram. When we are finding the angle, we draw the perpendicular from this point to the wire, and one angle is moving like this, one angle is like anti-clockwise theta 1, and one angle is like clockwise theta 2, right? So theta 1, one angle should be anti-clockwise, one angle should be clockwise. Now you see here, if you draw a perpendicular from this point O to the extended direction of the wire, so we will get two angles. One angle is coming as anti-clockwise, and second angle is also like the direction of, what is the direction of current? Direction of current is going like this, right? So we have to take, we have to draw, we have to join this point along the direction of current of the wire. So if you can see here, both the angle are in same direction, right? If you see from here, we will get both the angles are in same direction. Getting my point? Both are anti-clockwise here. Here you see, we have two angles. One is anti-clockwise, another is clockwise. But if you see here, both angles are in anti-clockwise direction. So the main thing is that we have to take one angle as minus 45 degree. And when you will, and the direction are opposite for V1 and V2. So when you will subtract, it will get added. Getting my point? When we will subtract, it will get added. Understood what I'm trying to say?
Yes, sir.
So that is why it is not cancelled out. Got my point? Since we are taking angle minus, so it will come in minus. The second angle is 90 degree. That is okay. That will be, that has already been cancelled out. But this 45 term will get added because of minus sign. Understood? Since you know, here we have taken, if you see this diagram, here we have taken theta 2 as positive when it is clockwise, but if you see here, the theta 2 is coming as anti-clockwise. That is why we have to take minus. So we have to be very careful while taking the angles. We have to consider sign also. That is very important. Got my point? So all of you try that question once again at your home. Try to solve by taking this angle, you will get the answer. Got my point? Moving to the next question. So all of you understood this one, both the questions?
Yes, sir.
Anyone having any doubt, please ask. You should not get with, you should not end up a class with a doubt. I always believe in that. If you take doubts with yourself, the doubt becomes bigger and bigger. So always try to all the doubts resolved in the same class. Never go back with doubt in your mind. Any doubt you have, ask me instantly. I will be very happy to resolve your doubts. I'm here to resolve your doubts, resolve your queries. So moving to the next question, we'll do same type of JEE question based on magnetic field. So these all are JEE questions. We have discussed this question number 4. This question 7, or you can solve. All of you try this question number. Try this question number 5. All of you try this question number 5. This is JEE Main 2019 question.
Sir, so the answer for the previous question will be option C, right?
That was, let
Pi
me
plus
check.
1.
It was 1 plus pi plus 1 by root 2, right?
No, sir. The 1 by root 2 and 1 by root 2 get cancelled and it'll be pi
No.
plus 1.
1 by root 2 is not got cancelled. You understood? Because of minus sign, and when we have taken minus and minus, it got added. Don't get it?
So
But
it's
we have,
minus sine 45, right?
yes, minus sine 45 degree. What happens? What was the direction of magnetic field due to first wire? It was outward, right?
Yes, sir.
B1 was inward, right? And B1 was inward and B2 was outward. There is no dot in the third part. It was separate thing, right? So what we have done like this: B2 plus B3. These both were outward, and minus V1, right? We have done
I
this.
got it, sir. I got it, sir.
Got it?
Yes, sir.
So this was. So all of you try this question. Is JEE in 2019 question.
Sir, option A.
You got option A. Anyone else? Kulsum, Samaira, what answer have you got? So it says two very long straight and insulated wires are kept at 90-degree angle from each other in XY plane as shown in the figure. Alright. The wires carry currents of equal magnitudes I, whose direction are shown in the figure. Okay. Then net magnetic field at point P. So we have to find net magnetic field at point P. These are two long current carrying wires. These are two long current carrying wires. All right. So so let us say this wire as 1. Say this wire is 1, this wire is 2. So for wire 1, what will be magnetic field at point P? What will be the value of magnetic field at point P? It will be mu naught I by 2 pi t. What is the direction? What will be the direction of magnetic field?
Outwards.
Yes, it will be outward. Similarly, we can find magnetic field at point P due to wire 2. 2 is this wire. So, what will be the value of magnetic field? That will be same mu naught I by this direction. This value is also, this distance is d. What will be the direction? It should
Inwards.
be inwards. So the net magnetic field will be Vp1 minus 2, and that should be equal to 0 since both are in opposite direction. Check again. You see here, yeah, one is coming out. There is no question of magnetic field along X or Y, right? And one is coming along outside. Yes, I think it should be 0. Your answer is correct. All of you understood? So all the options are misleading here basically. Magnetic field due to both the wires are in opposite directions and of equal magnitude. Understood everyone? So this is how we should approach for questions based on magnetic field due to uniform long wires or half wires or bent wires, right? We should approach in this way. Now moving to the next concept that is very important, and more of the questions I will give you as assignment. Number of questions are have to be solved in this. Generally, questions is certainly asked from this magnetic field part. So you have to practice more and more questions. I will give you more questions in the assignment also. So the next remaining part is, and other concepts you already know, force between two parallel current carrying wires, which you have already studied in class 12th lecture, that is mu naught I by 2 pi d I1 I2. This formula you all know, right? Force per unit length on two parallel current carrying wires. This also you know that two parallel current carrying wires attract each other and opposite current carrying wires repel each other. This concept, you know?
Yes, sir.
Let us see one more question in this segment. So I will solve. Can all of you try this question number 2? Give it a try. Not so difficult. Question second. Try this question. This is JEE 2020 question. All of you trying this question?
Yes, sir. So option D.
You got option D. Anyone else? So how you solve this?
Sir, I use the formula mu naught I theta by 4 pi r. And
Mu naught I by 2r into theta by 2 pi, right?
yes, sir.
Yes. That formula has to be used. So here we have, you know, if you see here, we have to find the ratio, right? So Kulsum also got D. So here what we have to do is, I have given a formula to find the magnetic field due to an arc, current carrying arc having angle theta. So the magnetic field formula was mu naught I by 2r, mu naught I by 2r, theta upon 2 pi. So this was the formula. Now here we see there are two sections of the wire. So A and B. So what will be the magnetic field? Both have same direction of magnetic field outwards at point O. So due to wire A, if we say magnetic field will be mu naught I by 2r. What is the theta here due to wire A?
270 degrees.
Correct, 370 degree. It means 3 pi by 2 divided by 2 pi. So it will be like, we will take outside mu naught by 2r, mu naught I by 2r. So it will be like 3 upon 4. Similarly, we will get magnetic field due to section B. What will be that? Magnetic field due to wire B will be mu naught I by 2r. What is the angle here for wire
5
B?
pi by 3.
It should be 300, right? So
Yes,
300
sir.
means
5 pi by 3.
correct, 5 pi by 3, and that will be divided by 2 pi. So it will be equal to, that will be equal to 2r. We will get 5 by 10, right? Sorry, 5 by 6. Get 5 by 6. Now we will take a ratio. So what will be that? Mu naught I by 2r will be cancelled out. So we will get the ratio. We have to find the ratio of magnetic field to the wire at A and B. So we have to find ratio of A and B. So we will get it as the required ratio as 3/4. The common term will be cancelled out, divided by 5/6. What will be that? 3 into 6/20. So we will get we were getting 9/10. How? It was mu naught I by 2r, 5 pi by 3 divided by 2 pi. So we got it 5/6, right? And here we were getting 3 pi by 2, so 3/4, right? So the ratio of 3/4 divided by 5/6. Current will be cancelled out.
Sir, it's not 4 hours, it's 4 pi, right? I think you you didn't substitute the value of R.
R,
Yes, sir, radius.
but we are taking the ratio, na, that will be cancelled out.
No, sir, the radius of both the arcs are
yes,
different. Right?
yes. Both the arcs are different, correct. And current is same, I think, shape of R.
No, sir, current is also different.
A wire bend is the shape of R carrying current of 2 ampere, having radius 2 centimeter. Okay, current is also different. Yes, so we are getting here 9/10, and also like here we can put the value. Yes, so here we can put the value. Mu naught by 2 will be constant, that is okay, and it is 2 by radius of the first wire is 2, right? So it will again remain 3/4, but in second case what will happen? So it will come as 3/4 into mu naught by 2, and here what we will get? We'll put mu naught by 2. What is the value of I in the second case? 3, and radius 4, right? Yes, that is 5/6. So this will be cancelled out, and we will get 6/5. Yes, mu naught by 2 into 3/4. 3/4 is common in both, so we will get reverse of that, 6:2. Understood? Yes. All of you understood this one?
Yes, sir.
So this was all from my side for today's class. In the next class,